Good morning, this is Dr. Turner for Integrated Math 3. Today we're going to be talking about 3.4 Part 2, which is looking at more advanced ways of factoring polynomials. We're going to really focus on quadratics because that is our emphasis for our standards. If we were in person, we would be doing other polynomials, how to factor cubic polynomials, so on and so forth. We're going to talk about a couple special cases that may appear on the test, but other than that, they're pretty straightforward. So let's go ahead and get started here. So before, we were looking at examples of factoring where we had a leading coefficient of 1, right? So a was 1. Remember that in your quadratic form, you're always looking at ax squared plus bx plus c. That's standard form. So in the previous examples in the video, we were looking at examples where a was 1. Now we're looking at examples where a is not 1. So for instance, let's say we had 2x squared minus 9x minus 18. Now, if I ask you to factor that, there's a couple ways you can do that. One would just be simply to kind of plug and chug, guess, see what you get, just like we did in the first part. So I know that for 2x squared, its factors need to go here. And I know that for negative 18, that its factors need to go here. And we're kind of doing the reverse FOIL method. So that would take care of our first and our last if we were to multiply it back out. The question is, well, when I add the outside and inside terms, right, my two linear terms, are those going to add up to 9x? So that's what we need to check. In this case, 2x squared only has two factors, so I know that it has to be, change the color there, it has to be 2x and x. Doesn't matter if it's x and 2x or 2x and x by commutative property. But now I need to figure out what goes here. Some people can do this in their head mentally, which is fine. Otherwise, you sort of have to write down your factors of 18 to see what's supposed to go in these spaces. So because it's negative 18, you could have a plus or minus, but 1 times 18, 2 times 9, and 3 times 6 are my factors. So I need to figure out what goes in this spot. So maybe I just pick one at random. I say, okay, 2x plus 1 and x minus 18. If I were to do that, again, I already know first, 2x times x is x squared. Last, 1 times negative 18 is negative 18. I'm checking to see if the outside and inside terms add up to negative 9. So I would do 1 times x plus negative 18 times 2. That ends up being negative 35, which is too high. So it's probably not going to be any combination of 1 and 18. So maybe I go to the next one. Try 2x minus 2 and x plus 9. 2 times 9 is 18, minus 2, that's 16, still too high. So it's probably not going to be any combination of those. So let's try 3 and 6. I'll do 2x plus 3 and x minus 6. 2 times negative 6 is negative 12. 3 times x is 3, and negative 12 plus 3 is 9. So this is this quadratic factor. Now that only took 3 tries of just trial and error. If I had a larger C term, let's say that was 36 or 64, then you could have, up to 10, 20 different factors that you could potentially have to check. So it's not the most effective method, but it is a method to do this. Usually if you're taught this in school, they ask you to do the magic X. And there are other ways to do it. You can do factoring by grouping and all sorts of different things, but the X is the most common. So just like in the first video, we have B on the bottom, which is going to be a sum. And on the top, we have a product, whereas before it was just C because A was always 1. Now we're looking at A times C. So let's say I wanted to do this same quadratic, 2x squared minus 9x minus 18 using the x. In the top, I'd be doing A times C, so 2 times negative 18. And then I'd be doing B in the bottom, which is negative 9. So I'm looking for two numbers that add up to negative 9, but multiply to get negative 36. And just like we did here, that may take a little bit of trial and error, but eventually we end up with a positive 3 and a negative 12. 3 times negative 12 is a negative 36, and 3 plus negative 12 is negative 9. Now, when we were doing a leading coefficient of 1, it was just x plus 3 times x minus 12 and we were done. But that's not what we got up here, right? So we're missing something. Well, what you have to do is you have to actually take these values and you have to divide it by your leading coefficient. And this is what that's going to look like. So it's going to be x plus 3 over 2, dividing by the a term, and then x minus 12 over 2, divided by the c term. Now, what you can do to clean this up, obviously on the right, 12 divided by 2 is 6. And on the left, because this factor could stand by itself, what you do is you multiply both values by 2. And now it looks like what we had up in the top. Let's look at another example. Let's take, I'll put it over here, 6x squared, 6x squared minus 11x minus 35. I want to factor this. The same thing, I'm going to do the x. And these are a little bit bigger numbers, but still doable. 6 times negative 35 gives me negative 210. B is negative 11. So I'm looking for the numbers that multiply to get negative 210, that add up to negative 11. After a little bit of arithmetic, we end up with 10 and negative 21. So factored, you can write this as x plus 10 times x minus 21. And then remember, we have to divide by our a term on both. You can clean this up. 10 divided by 6, that can become 5/3. X minus 21 over 6, divide top and bottom by 3. And then you could leave it like that technically because it's going to give you your solutions, but if you wanted to clean it up a little bit further, you could multiply here both by 3 and here both by 2. Because the next section is going to be talking about solutions for me, if you want, you can leave it at this step, but some instructors will ask you to write it out without fractions. And let's do one more. 4x squared plus 11x minus 3. So on the top, 4 times minus 3. On the bottom, 11. The numbers that multiply to get negative 12 but add up to 11 would be my computer's messing with me here. The numbers that multiply to get negative 12 but add up to 11 would be a positive 12 and a negative 1. So that is x plus 12 times x minus 1. Divide by the leading coefficient, which gives you x plus 3 times x minus 1/4. And then again, if you want, you can multiply that right binomial by 4 to make it 4x minus 1. So hopefully these ones are pretty straightforward. And I'm going to go ahead and give you a second here if you need to pause it and screenshot and clear the page. I mentioned that we could potentially, if we were in person, be doing factorization of larger polynomials. We're going to omit that. However, the one special case I want you to be aware of is what's known as the sum or difference of cubes. So there are two formulas here. Your sum of cubes is a cubed plus b cubed. And that is equal to a plus b times a squared minus ab plus b squared. And the difference of cubes, a cubed minus b cubed, is equal to a minus b times a squared plus ab plus b squared. So in some textbooks, what they'll do is they'll combine these two into a single formula. And Sometimes that confuses students, so if you want to write them out separately, you can. But some textbooks, like I said, will write it as a single formula. So it would be a cubed plus or minus b cubed equals a plus or minus b times a squared minus or plus ab plus b squared. So by now you're probably familiar with the plus or minus sign. The minus or plus sign might be a little new to you. Basically what this is saying is that when I look at these two symbols have to be the same, okay? And then these two symbols have to be different. So if this is a plus, then this is a plus and this is a minus. If this is a minus, then this is a minus and this is a plus. So that's how that's written out. Again, if that's confusing, you can just leave it as the two separate formulas. That's fine. So just like before when we were looking at difference of cubes, for instance, back in the first part of this section, if I saw something like x squared minus 64, I should be thinking perfect squares. I know 64 is a perfect square, and I can write it as x plus 8 times x minus 8. Right? That was the last section. Here, it's the same idea, but instead of looking for perfect squares, I'm looking for perfect cubes. Now, I mentioned in class for the last section that I kind of expect you by now to have your perfect squares memorized at least up to 20. So 1 squared through 20 squared. Most commonly, if you're on a standardized test, you're going to see typically 13 down. So 169, 144, 121 going down. With cubes, really like 1 cubed, and you can put this in your notes if you'd like, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. That's typically as high as they'll go. Sometimes they'll throw in a 6 cubed, which is 216. And if they do anything higher than that, typically it's something like a 10, right? And anytime you do a 10, it's just adding another 0. So 10 cubed is 1,000. So those are the most common cubes. So if I have an x cubed plus or minus one of these numbers, I should be thinking, hey, I can factor this using sum or difference of cubes. So let's look at a couple examples like that. X cubed plus 8. 8's a perfect cubed, so we can do that. So I recognize that 8 is a perfect square, and so I can write this out. If 8 is a cube, then that means it's 2 cubed. And so if it helps to recognize what a and b are, you can rewrite this as 2 cubed. And in doing that, this is now just fill in the a's and b's. X plus 2 times x squared minus x times 2 plus 2 squared. And of course, we'd want to clean it up a little bit. X plus 2 times x squared minus 2x plus 4, like so. You know, you don't have to rewrite it as 2 cubed, but I think it helps just so you'd see what is a and see what is b exactly. Let's do another one. X cubed minus 125. Same thing, if you want to take that step, rewrite 125 as 5 cubed, so you see what a and b are. Then fill in your a's and b's. So x minus 5 times x squared minus x times, plus, right? It's the opposite sign, plus x times 5 plus 5 squared. This becomes x minus 5 times x squared plus 5x plus 25. Do one more. Do x cubed plus 1,000. So 1,000 is 10 cubed, which means this is x plus 10 times x squared minus 10x plus 100. If you're ever in doubt, remember you can always go backwards. You could distribute this, combine like terms, and double check that you are correct. But as long as you're using the formula carefully, you should be okay. That's pretty much it for right now. Again, we could make this more complex, but because we're doing it online, I'm trying to keep it to the basics. We will probably talk, if we have time by the end of the semester, of how you factor larger polynomials, and we'll talk a little bit about it in 3.5 with solving polynomials. That's all for today, guys. If you have any questions, please reach out to me, and I'll talk to you soon. Bye.